So we continue the exercises. So we start from exercise 25.1. And we have A is the set, B is the set. We want to list each. So list all functions from A to B. So what we have 25.1. So our A is that one. So we have here 1, 2, 3. Here we have xy. So the first function, maybe the easiest one is 1 go to x, 2 go to x, 3 go to x, right? So this is the first one, and the second one, 1, 2, 3. This one is xy. Yeah. So what we have, so 1 to x, 2 to x, and then 3 to y. Correct, right? And then the next one, there are so many. Why? Because each element has two choices. So we have in total, it should be here, two choices, two choices, two choices. It should be 2 power 3, 8 possibilities. Right. So in total, it should be 8. So this is the first one. This is the second one. 1, 2, 3. Here go to xy. Maybe number 2 go there. And then here 1, 2, 3 xy. We have 1 go there. The rest still here. And then this one is for one element going to y, and then 2 elements going to y, then 1, 2, 3 xy. I think I should add another one. So what we have, we still miss 4 more, right? So when one element go to y, I think that's all. And then we need 2 elements go to y. So here 1 to x, and then we have 2 to here. And then what's again? We have here 1, 2, 3 xy. So what we do here, 2 to x, and then the rest go to y. Here y, go to y, and then here 1, 2, 3. Here 3 to x here, and then the rest go to y. And this is the last one, 1, 2, 3. Everything go to y. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So it's already 8 functions. And we would like to check whether is it injective, surjective, or bijective, or none of above. So the first one, is it injective? Injective, right? And then the second is surjective. Am I missing my voice? I should be no, right? So my my speaker is on. So for the first function, is it injective?
No.
No. So not injective, and then is it surjective?
No at all.
No also. And then not both, right? And then how about this one? Injective? No. Yeah, correct, because x everything goes double that. And then surjective, that's fine. And this one also cannot be injective. Why? Because imagine if you have 3 pigeons and you have 2 holes, and then at least there is 1 pigeon which contain more than one. There is 1 hole, at least 1 hole, where it contains more than 1 pigeon, right? Or maybe if you have 3 boxes, 3 balls and 2 boxes, and then you want to put here, so it is quite clear that one of them should contain more than 1. Why? Because if you put 1 here, and then the last one should go to one of them, right? So cannot be injective at all. So number 2, this one also subjective, this one also subjective, this one subjective, and then this one also subjective, this one also subjective, and this one not at all. Okay, hopefully that's clear enough. And then we try for the second question. Do all function from B to A. So how about B to A? That will be the same thing, because here we have here 3 choices, and yeah, it should be 3 square, right? Because X can go to 1, 2, or 3. This one also can go to 1, 2, or 3. So it should be 3 square is 9. So let's list all of them. This one 25.1, still the same. So we have XY here 1, 2, 3. Here again XY here 1, 2, 3. And then XY here 1, 2, 3. And then again XY 1, 2, 3. XY 1, 2, 3. And then here XY here 1, 2, 3. And then here XY 1, 2, 3. XY 1, 2, 3. And then here XY here 1, 2, 3, right? And then yeah, everything go to 1. That's the first one. And the second one, X can be 1, and then X still 1, I think. That's the easiest way to list. And then Y go 2, X still 1, Y go 3. Correct? And then X go to 2, Y to 1, X go to 2, Y go to 2, X go to 2, Y go to 3. And then X go to 3, Y go to 1, X go to 3, Y go to 2, X go to 3, Y go to 3. Okay. So this one cannot be subjective. Why? Because yeah, imagine if you only have 2 balls and then 3 boxes. So it is impossible to fill all boxes because you lack of balls. So it should be clear, cannot be subjective. But right now we only check which one is injective. So this one is not injective because one, we have 2 there, and then this one is injective. This one also injective. This one also injective. This one not. This one injective. This one injective. This one injective. This one no. Okay, so that's the idea how to list all possibilities. So we are not only try to list the possibilities, but we have to make sure that one are all of them. So that's the challenge of this question. Any question maybe? 25.1. Okay, no question. So we can continue for the next one. Which one correct? 25.2. Is it injective and or subjective? Is it injective first? For A. 25.2 A. Is it injective? Should be correct, right? This one is injective. Okay. And is it subjective? Do you get confusing? Do you get confused for this one? We have F is from C to Z. Hopefully you are not confused. N go to N plus 1. So for the injectivity, we take 2 here. So 2N1 plus 1 is equal to 2N2 plus 1. So this one should be clear because we cancel number 1, cancel number 2. So N1 is equal to N2. So we can conclude that this one is injective, right? And then how about the subjectivity? So as I mentioned before, we know that we have Y is 2N plus 1. And then what we have y minus 1 over 2 is equal to n. But the problem here is we have n is z, right? In z, right? So it's an integer, and the result from this what may not be an integer. That's the problem. For example, like when y is equal to 2, then it's not an integer anymore. Correct? So there exists y is equal to 2 such that for every n in C, 2n plus 1 will not be equal to 2. Okay, hopefully that's clear enough. And so this one, the conclusion is it is not surjective. Okay, and then for the next one, G from R to R, G from R to R, and then we have x squared plus 2x plus 2. X go to x squared plus 2x plus 2. And this one is equal to x plus 1 square. Then x plus 1 square is x squared plus 2x plus 1. But we have plus 2 here, so we have to add 1. Okay. And yeah, so if you get like this, x plus 1 square, so when you have x is equal to minus 1, then you get here, right? So basically x square is this. This one, y is x square. And then what we do, we try to move to the left with this coefficient 1, and then move up 1. So this will be something like this. Okay. So this one is y equal to x squared plus 2x plus 2. Yeah, something like this lah. But I know that my drawing, my picture is lousy. But yeah, hopefully that's clear enough. And any question? Okay. So there is a blackout. Yeah. Yeah, sometimes that happen because it is raining right now. So we can do the horizontal test here. And we know there are 2 points that get cut with that test. And also we also can do horizontal test here, and it doesn't intersect. Okay. So this one, yeah, the easiest way is, what is this? X plus 1 square plus 1. So if I take 2, so I have 2 plus 1 square plus 1. What is it? 3 square plus 1 is 10, right? And then what again? How to get this one become minus 3? So because this one 3 square, right? 3 square and minus 3 square, yeah, are the same. So I have minus 4 plus 1 square plus 1, right, is equal to 10 also. So s equal to, and then x is equal to minus 4. So 2 is not the same as minus 4, but when we have like this, we have g2 is the same as g minus 4. So this one is not injective. Okay. And how about the surjectivity? As I mentioned before here, so it doesn't intersect. So maybe I can take maybe minus 2 in R, such that for every x in R, what we have, x plus 1 square plus 1. So this one is greater than or equal to 0. And then plus 1, so the whole thing will be greater than or equal to 1, right? So they cannot be equal to minus 2. So the conclusion is not subjective. Okay, any question maybe? So this also answer the previous question, like how to, yeah, but I draw the picture, but I mean, if I don't draw the picture, that will be the same. So if this one disappear, the picture disappear, that's also the same. So we can do the same way. But yeah, here my position is to explain the answer. That's why I try to make it as clear as possible. Even you don't draw it, that's also fine. So that's way to give you the same result. Okay, no question. So we can go for the next one. The next one is from what is it? It's from Z to Z. And then we have N, go to N plus 3. So what is it? Is this injective? Should be yes, right? Because we have N1 plus 3 will be equal to N2 plus 3. Then this one will implies N1 is equal to N2, right? So for the quantifier, I think you can complete it by yourself, but this is the main idea. So you take two number such that the maps are the same, blah, 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 right? But the key point is this one. And for the next one, this one is injective. So how about the subjectivity? So this one, take any. So basically in your stretch of paper, you can do this N plus 3. So your N is Y minus 3. So Y minus 3 should be okay, right? For every integer. So take any Y in Z, right? So there exists your N is equal to Y minus 3, such that, what is it? H of N here is H of Y minus 3 here, Y minus 3. So what is it? Y minus 3 plus 3. So it will be equal to Y. So this one is surjective. Okay. Any question maybe for point C? So at least I have explained the key idea. So I think for the complete writing, you can do by yourself. It should be okay to leave it for your exercise. Hopefully that's clear. Is that clear? Yeah. Okay. Yeah. Next we have 25.3. So this one we have 25.3. We have F from Z5 to Z5. We have A bar will go to A bar plus 3. Here. We want to prove that it is well defined. So what we have, when we have A1 equal A2 bar, right? So what is it implies? We have there exists K in Z such that A1 minus A2 is equal to 5K. Correct? This one is because of the relation. So we have they are in Z5. So they are in the same class when the difference is multiple of 5. So what we have from here, then we have here 2A plus, or if not this one, we have FA1 minus FA2. What we get here, what we get is here we have 2A plus 3 bar minus this one A1. This one we have 2A2 plus 3 bar, right? And in terms of modulo 5, we can do like this. The whole thing, 2a1 plus 3 minus 2a2 minus 3. So what we get, 2 times a1 minus a2. Bah. Okay, this one is multiple of 5. So this one 10k bar, and this one is 0 bar. So what is the meaning? Yeah, the meaning is f a1 bar equal to f a2 bar, right? Because the difference is 0. So yeah, we can say that f is well defined. Okay, any question maybe? So well defined means whatever you take here, maybe for example like 0 bar, right? 0 bar is equal to 5 bar, equal to 10 bar. So whatever you choose there, then they will not change the result. Will be the same result. That's the meaning of well defined. And then from point B, is it injective? Is it surjective? The easiest way is, yeah, just draw the diagram. So here we have Z5, and then here Z5. We have 1 bar, 2 bar, 3 bar, 4 bar, 0 bar. 1 bar, 2 bar, 3 bar, 4 bar, 0 bar. Right. And then what we do, 2a plus 3. Yeah. So when a is equal to 1, 2a plus 3, what is it? 2 times 1 plus 3 is equal to 5. This one is 0. Correct? So what you have here is 0. So 1 go to 0. And then when a is equal to 2, 2 times 2 bar plus 3. Because when you take this one, so this one is equal to 2a bar plus 3 bar, right? And then what we have here, 4 plus 3 is 7. 7 is 2. So 2 is going to 2. Yeah. A is equal to 3. What you have, 2 times 3 bar plus 3 bar. Then that will give you 6 plus 3, 9. 9 is 4. So 3 go to 4. A is equal to 3. What you have, 2 times 3 bar plus 3 bar. Hey, this one is 4, right? 4. 4. So 8 plus 3, 11. So this one become 1. So 4 go to 1. And then 0. A equal to 0. Then 2 times 0 bar plus 3 bar is 3 bar, right? This one go to here. So it's clear this one is injective and then surjective. Okay. This is one way to prove that. And the alternative, we can use the hint. So for example, like this, what you get when you have f a bar or f a bar is equal to 2a bar plus 3. Okay. So what you have, you can find the inverse. So f a bar minus 3 bar is equal to 2a bar. Yeah. And from here, what you have, a bar is, if you multiply by 3, 2 times 3 is equal to 6, and 6 is equal to 1. So we multiply with 3 here. 3f a bar minus 3 times 3 is 9. So we have a 4, right? So we already find the inverse. So it should be injective and surjective. Okay. Any question maybe for the third question, the third explanation? Okay, no question. So I can continue for the next one. 25.4. We will find a function from R to R that is neither injective nor surjective. Okay, yeah, I think we already mentioned before, right? When we have fx, So we have fx is defined as x squared plus x plus 2. So this one is not surjective, right? So it should be okay. And both injective and surjective, we also can do fx is equal to n plus 3, like we mentioned before. So that's for the 25.2, right? From that one. So that one should be okay. And then anyone know how to define the injectivity but not subjective? B and C. And this one, the domain is the set of real number and also the codomain. Any idea? Because when we try to fx to n plus 1, this one also subjective, right? Because we can divide by 2, right? Previously for this exercise, this one is in Z, right? So that's the key. But this one, it is okay. So for this one, the easiest way is injective but not surjective. You can see e to the x. Okay, so this one is injective, and e power 0 is 1, right? So it should be okay. And how about the surjective but it's not injective? This one, if you draw, this will be like this. 0 become 1, and this will go dramatically, and this one go to here. So as you see here, for below the horizontal axis, there is nothing there, right? So you cannot intersect with the curve. That's why it is injective, but it is not subjective. Because if you do the horizontal line test in the above the horizontal axis, I think it's very clear that it's only cut through the curve only exactly in one point. So for the last one, subjective but not injective, any idea? No idea. Oh, are you sure? Have you tried it? Maybe only one of you, right? So maybe we also can do this like tangent, because if you know tangent is like this. So whenever you make a horizontal line, and then you will get something lah in there. So they have a pre-map, but the problem is it is repeating, right? So it cuts you more than once. So that's why it is not injective. Any question maybe for 25.4? Okay, no question. Are you sure? Yeah. Okay. Okay. Hopefully that's clear. And this one is for the last one because we run out of time. And for point A, do you know how to do this? So this one is, the only question is to check fx cannot be equal to 1, right? So they only ask when is it equal to 1. So just check it. So when it is equal to 1, so that's the question, right? 25.5. 25.5. So what we have here, fx is equal to x minus 3, x minus 3 over x minus 2. So it cannot be equal to 1. Cannot be equal. So how to prove? If, right, there exists x in R minus 2, such that fx is equal to 1, right? So what you have here, x minus 3 over x minus 2 is equal to 1, and then x minus 3 is equal to x minus 2, and then cancel out x, yeah, and you have minus 3 is equal to minus 2, yeah, and this one is contradictive. So we have a contradiction. Why? Because minus 2 is not equal to minus 3. So yeah, that's why we call it is a function. Okay. For point B, we would like to prove that f is injective. So how to prove? I think almost the same like what we have before. So take any x1, x2 in here. So r minus 2 here, where fx1 is equal to fx2. So what we have, x1 minus 3 over x1 minus 2 is equal to x2 minus 3 over, what you have, x2 minus 2. So this one will implies x1 minus 3 is times x2 minus 2 equal to x2 minus 3 times x1 minus 2, right? And blah, 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 blah. We will get x1 times x2 in both sides. So this will be canceled out. And then what you have, minus 3 times minus 2 is equal to 6. 6 also will be canceled out. So this will be disappear. And what you have is only minus 2 times x1, minus 3 times x2. And this one is minus 2x2 minus 3x1, right? So what you have here, yeah, just right, just add 3x1 in both sides. So you have x1, and then you also can add 3x2 in both sides. So you have x2. So that's why we got this one, f is injective. So how about the surjectivity? Yeah, again, in a stretch of paper, you can do y is equal to x minus 3 over x minus 2. Then what you get here is you have xy minus x, right, is equal to 2y minus 3. Okay, so x is equal to 2y minus 3 over what you have here, x minus y minus 1, right? So for every y in r minus 1 here, there exists x is equal to 2y minus 3 over y minus 1. Because y is not 1, so this one is defined such that what you have, f from x is equal to f from here, 2y minus 3 over 2y minus 1. Right. So from the definition, what you get here is 2y minus 3 over y minus 1. And then you add this with minus 3 over 2y minus 3, right, over y minus 1. You add this with minus 2. And blah, 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 blah. The final answer you will get, this one is y. So the answer is f is subjective. Yeah. Any question maybe before we end our meeting? Okay, no question.
Not yet, sir.
Okay, good.